Okay, the first thing I'm going to do in this video is going to take a minute. We're going to look at number 8. A pair of dice is rolled. One die is red and the other is green. So basically we're thinking of a first die and a second die. A red one and a green one. First, second. How many possibilities are there? That is, how many elements are in the sample space. And then write out the sample space. So all of the possibilities would be like this. The sample space would be, now here's what I should write one roll being something like, I should do it like this, where the first one is a 2 and the second one is a 3, put them in commas and put parentheses around them. I'm going to make it a little bit quicker and shorter. So instead of doing this for the first one, 1, 1, I'm going to make it look like an 11. But what that means is you rolled a 2 if you're adding the numbers up. 1 and 1 is 2. So that first row is going to be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Now I'm going to start the second row. That's all of the outcomes where the first die was a 1. Now I'm going to get a 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. And then a 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. 3 more rows. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And then the last row, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. That's the sample space. If you count those up, you'll find there are 36 possibilities, going from 1, 1, 1, 2, and so on, and ending at 6, 5, 6, 6. Remember, in most games when you roll 2 dice, you add up, you get the sum. And that's what we're going to do in our questions, our probability questions. But once you have this drawn out, it'll make the questions very, very simple to answer. Okay, find the following probability that the sum of the two numbers is 3. Well, let's find how many of these numbers, of these 36, have a sum of 3 when you add them together. This one's a 2, 1 plus 1. Here's a 3, 1 plus 2. And look down at this diagonal, we get 2 plus 1. 1, 2, and 2, 1. That's the only way you can roll a 3. There is no 1 1/2, 1 1/2. These are all nice whole numbers on the dice. So there are 2 ways to get a 3 out of 36. So I'm simply going to write 2 over 36. I could reduce that, 1 over 18 if I wanted to, but I'm not going to, and I usually won't require you do that on an exam either. If you're doing something by rolling 2 dice and you have 36 possibilities, just keep 36 as the denominator, and then in this case it was 2 over 36. Okay, the next one. What's the probability that the sum of the two numbers is 11? I need to know how many of these individual events, outcome, how many of those 36 outcomes would give me an 11? The only way to get 11 on 2 dice is a 5, 6 or a 6, 5. These two, 1, 2. So again we get 2 out of 36. So it's equally likely to roll a 3 as it is to roll an 11. What is the probability that the sum of the two numbers is 6? Well, the nice thing about finding the sum of the two numbers is you can look at a diagonal here. The 6's are all above that sheet of paper. Let me see if I can get that. Yeah. It goes from 5, 1 That's 6, 4, 2, 3, 3, 2, 4, 1, 5. So that one diagonal there that has 1, 2, 3, 4, 5 elements, that's the only way you can get a 6. Those 5 different ways. So there are 5 ways. So 5 over 36 is the probability of getting a 6. And by the way, the most commonly rolled number, you've heard of lucky 7 before? That's this diagonal right here. So the probability of getting 7 is, let's see, there's a 7, that's 7, that's 7, that's 7, that's 7, and that's 7. Those 6 of them roll, those 6 are the ways to get a 7. So 6 over 36 would be the probability of getting a 7. 7 is the most likely to get number to get when you're rolling 2 dice. The last one says, what's the probability of getting doubles? Well, the doubles are easy to find. This diagonal. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So there are 6 possible doubles with the 1, the 2, the 3, the 4, the 5, and the 6. So that's going to be 6 over 36. Anytime you have dice questions where you're rolling 2 dice, it will benefit you in the long run if you write out this whole sample space in this way. Don't write them all on one line. It's harder to count that way. Make this little grid, 6 rows, 6 column grid. All right, number 9. Joe tosses a coin 3 times. Draw a tree diagram to obtain all of the possible outcomes. I don't generally ask you to do the tree diagrams on an exam, but they are very helpful. They can be very helpful anyways. Let me make the drawing here. All right, when you toss a coin, the first coin, there are 2 outcomes possible. I'll write them along the edge, the path here. Heads or tails. That's the first one. You end up either here or here. And then you've got 2 choices here, 2 choices here. Either heads or tails, either heads or tails. And then one more time, I'm going to have to draw them a little thinner, I think, here. Okay, so H, T, H, T, H, T, H, T. That's my tree diagram. That's all the possible outcomes. For example, the path that takes you from this point, we sometimes call it a vertex or a node, from this node to this node would be H, H, H. This here would be HHT. And these are all the possible outcomes. Then we get to HTH, and then HTT. Now we start with, to get down to these 4, we start with the tails. THH, THT, TTH, and TTT. That is the 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes when you roll, or excuse me, when you toss a coin 3 times. This is all of the possibilities. So you can guess that they're all equally likely. This first one, oh, looks like I wrote that one incorrectly, HHH. Getting an HHH, 3 heads, is the same probability as getting an HHT or an HTH. These are all equally likely to occur. So there are 8 possibilities, which means every one of these has a probability of 1 over 8 occurring, each one of those. All right, let's find the probability of exactly 2 tails. So we need to go through these 8 and count up exactly how many of them have exactly 2 tails. All right? This is no, 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 yes. This one has 2 tails. So 1, no, yes. This one has 2 tails, the first and last one. And this one has 2 tails, the first and second one. This one has 3, so it does not have exactly 2. So there are 3 of them that have exactly 2. So the probability is going to be 3 over 8 because there are the 8 possible outcomes in our sample space. Yeah, this is the list of the elements in our sample space for this experiment. So all the denominators are going to have 8. Now, if you reduce them, it won't anymore, but this one doesn't reduce. But okay, so how about at least 2 heads, at least 2 H's? Another way of saying that would be either 2 or all 3 are heads. At least 2 means 2 or more. There's one. This one has 2 H's. That's 2. 3. 4. So half of them. 4 over 8. That's the probability. So one half of them have either 2 or 3 heads. Double check. 1, 2, 3, 4. Yep, 4 over 8. Okay. How many of them have at least one of each? 1 H and 1 T. Well, the only ones that will fail that are the ones that have 3 H's, like at the top, because it doesn't have a T in it, and then the 3 T's at the bottom, because it doesn't have an H in it. Every one of them in the middle has an H, at least 1 H and at least 1 T. So the 6 in the middle have at least 1 H and 1 T, so that would be 6 over 8. And the last one. Find the probability of no 2 consecutive tosses identical. So remember, we've got 3 tosses going on. So we're not allowed to have, no HH anywhere in it and no TT anywhere in it. So let's count up the ones. That's got consecutive H's, so does that. This one doesn't. This one counts. That's a HTH, so no 2 consecutive anything. 1, that's consecutive. That's consecutive. 2, and that's 2, so 2 over 8. Yeah, that seems right, because to have no 2 consecutive being the same, that means it has to be heads, tails, heads, or tails, heads, tails.